GraphQL is what's known as strongly typed. When a query or GraphQL operation is executed, the data returned is validated against a type system. Each data field that we tell GraphQL about, for example this all films query as well as its subfields, has a specific type against which it's going to be validated. If the type of data returned doesn't correspond to our schema, we're going to get an error. We can already infer what the types of data that we specified within our query might be from taking a look at what's returned. We can see that all films is an object, since it has curly braces and one property on it. Films is an array of objects, and title is a string. So all of these defined types, along with their corresponding fields, form an entire type system or schema. And this type system is basically a blueprint for our data. GraphQL types specify the shape that our data should have, the names of the fields, and the types of each data that must be returned. So in creating our own applications in this course, we're going to be setting up our own type system or schema, and that schema is going to be written according to the pieces of data that we're going to have within our app. We can take a look at the schema for our Star Wars API by heading to the Docs tab in the top right hand corner. And immediately we see within this documentation explorer that allows us to explore our GraphQL schema that we have this list root types. If we investigate this root types list, we see that query within GraphQL is its own type, the type root. We call this particular query listed in root types as the root query type. And for every GraphQL application, you're going to have one core root query type that all of your individual queries are going to be defined on. So if we click on root here, we can see all of the individual queries, or expressed differently, fields of the root query type. And this list tells us what fields are available to select on the query type. So if we take a look at our all films query, we first see the field name all films, and then after the colon here, we see the type of data that this query returns. We see that it's a custom data type. As we saw from our JSON response, it is an object type. So if we click on this films connection, we see the subfields that we can get on it. And if we scroll down, we see our films subfield. And if we see what it returns after the colon, it's an array, as denoted by these two brackets, an array of objects. And this object type is called film, so let's click on that. And then we can see at the top of the list the field within films that we queried for title. And title is of type string. In the GraphQL query language, fields can either be scalar types, what's known as scalar types, or object types. We saw a couple of examples of object types. They can contain their own set of subfields. They just, generally speaking, have to be an object. But scalar fields refer to built-in GraphQL data types. There are 5 built-in scalar types: integers, denoted with int, as you can see here for the episode ID field, floats, which are decimal numbers, strings, in the case of our title, booleans, either the true or false value, and IDs, which are basically unique strings. We'll cover types in more detail when we work on our Python backend, but for now just remember these two main types, scalar types and object types. And one last thing worth covering in relation to our type system is that our queries and GraphQL operations can accept values, and these values that we pass to queries, these arguments, just like the data that's returned, the arguments must be defined within our type system, and the values passed to those arguments must correspond with the data types that we have declared within our schema. So let's take a look at a different query. For example, this film query, and we can see its list of arguments here within parentheses. And for this film query, there are 2 arguments, one named ID, the other named film ID. And then after the colon for each of them, we can see the type that must be passed to that particular argument, and they both accept values of type ID. Again, this is a scalar type in GraphQL. So let's search for a Star Wars film. Let's query for a Star Wars film according to its ID. So within a set of curly braces, we'll write the name of our query, film, and then to pass a value to our ID argument, we can add a set of parentheses, and again we get IntelliSense with arguments as well as the names of the operations we want to execute. So we'll provide the argument name ID, then we'll add a colon, and then we can provide the value that we want to pass to it. So again, as I mentioned, an ID is just a unique string. So we'll add a set of double quotes, and we'll grab the film with the ID of 1. We'll add another set of curly braces for the subfields on film, and if we look at what film returns after the colon, we click on the film object type, we see that we can get a bunch of different fields. And again, since we can request whatever we want, we can choose to include or remove any set of subfields that we like. So here I'm going to ask for just title and episode ID. So we're not getting any red squiggly lines, so there's no errors in how we've written this query. So let's hit the play button to execute it. And we're getting an error, no valid ID extracted from 1. And this is because I actually want to use the argument film ID. And now when we hit the play button, we should get the film with the title A New Hope and the episode ID 4. And note what happens if we pass in the wrong data type to this argument. Let's say instead of 1, we pass in the Boolean value false. Well, number 1, we get a red squiggly line telling us before we even execute this query that it expected type ID for this argument but found false. And if we hit the play button, we're going to get an errors array with a message including the same message text. So this is what it means for GraphQL to be strongly typed. We need to pass in the appropriate type of data to our arguments, and if the data returned from a given field or a subfield doesn't correspond with the types that are declared within our type system, we're also going to get an error message, very much like the one that we just saw.